Hello everyone. So for today we are learning on calculating reacting masses. Okay, so step to success. Firstly, you need to know how to find the relative atomic mass of the element present in the chemical formula from the periodic table. This one we have done on last week, right? Previous weeks. Then next we need to know how to calculate the MR. MR means the relative formula mass or relative molecular mass for the elements or and the compounds stated in the chemical equation. Next, you need to be able to make ratio between two known masses. Later I'll show you how. And lastly, you'll need to be able to use cross multiply to find the unknown mass of the reactant or product. Okay, this one also I'll show you how. Okay, example 1. The question stated here, carbon dioxide react with carbon to produce carbon monoxide. Then you can see there's an equation here, CO2 plus C to form 2CO. Part A, they have written the question, the sentence here. The relative molecular mass for carbon dioxide is 44. So which means if I zoom here, carbon dioxide is this, right? You learned it before. So the MR, relative molecular mass, MR, is 44. Next, part 1, they ask you calculate the relative molecular mass of carbon monoxide. So which one is carbon monoxide? Read back the question. Carbon dioxide react with carbon to form carbon monoxide. So this one, carbon monoxide, is here. As you know, carbon monoxide goes by the formula of CO. Okay, so you only calculate the CO without the 2. Alright, so how to find the relative molecular mass? Find the mass for carbon in the periodic table. How much is it? It is 12, right? Next, what's the mass for oxygen in the periodic table? It is 16. So 12 plus 16, it is 28. That's all. Got that clear? Alright, next, A part 2. You are required to complete the following sentences. 44 gram of carbon dioxide will produce blank gram of carbon monoxide. So let's go back to the main question. 44 gram. So here carbon dioxide, we know the relative molecular mass is 44. So gram is mass, right? So let's write down the ratio. So firstly, we go back to our step to success. The third step, you need to be able to make ratio between two known masses. So the two known masses you need to make ratio is between carbon dioxide and carbon monoxide. So I'll just circle these two and these two, then I will carry it here. CO2 to the ratio of 2CO. Whatever you see in the equation here, you must carry. You must carry. Next row, you must write the MR, relative molecular or formula mass. So as we know, the MR for carbon dioxide is 44, right? So what about the relative molecular mass for carbon monoxide? Carbon monoxide we have calculated here earlier, right? It was 28 for one carbon monoxide. Here it is 2 from the equation, so you need to obey. So if 2 carbon monoxide, you need to multiply with 2 from the 28. So find out the value. So 2 times 28, you get 56. So let's read back the question. 44 gram of carbon dioxide produce blank gram of carbon monoxide. So does this 44 exactly the same as in here? It is the same, right? So therefore 44 gram of carbon dioxide, alright, read the column here, indeed will produce 56 gram of your carbon monoxide. So therefore 56 is the answer here. Everyone got that clear? Alright, lastly, there's one last sentence. 1.1 gram of carbon dioxide produce blank gram of carbon monoxide. You can't see where is 1.1 from the equation. You can't see, but you know it is a fraction of your carbon dioxide. So what you need to do, you just need to put the 1.1 gram of carbon dioxide underneath the column here, underneath for your carbon dioxide, to the ratio of, do you know the mass for the carbon monoxide? No, right? So it's a unknown x, so I just put an x. So if I zoom here, do you remember what to do for your mass? You remember cross multiply? Put a cross like this, then the x bring to the other side becomes multiply, the 1.1 bring to the other side also multiply with the 56. So here we go, 44 multiply with x, 44x, then 1.1 bring to the other side, 1.1 times 56. So x is equal to 44, you need to bring to other side, become division, 1.1 times 56 will become 44. Then work out the value of your calculation, then you should get 1.4 gram. So therefore, lastly, the answer for this last sentence, 1.1 gram of carbon dioxide will produce 1.4 gram of carbon monoxide. So I hope everyone can understand this explanation.